Aaon has made mistakes, things to look for. The class that I'm doing, I'm going to be teaching more about troubleshooting, doing more troubleshooting, more tech related stuff. So if you are looking for design stuff, criteria, stuff like that, I don't really cover a whole lot of that in the class. I run through stuff quite rapidly. If y'all don't understand something, I'm the world's worst. I'm going to tell y'all right now that I run through things fast. I assume everybody understands. If y'all have a question, stop me, please. That being said, this is your PCMX board. Just the general layout of it. You got up top, you got communication bus. If you're plugging into one of these boards, there's a couple of methods to plug in. One is a handheld service tool. Second one would be a USB link or a COM link. We go in here, communication bus, all the same. Communication bus here for expansion modules, expansion devices, which is the eBus connector. We got an EEPROM right here. They did away with that on the new boards, and I'll show y'all some of the new boards. Whenever you call in to do some troubleshooting, have this number with you, have it handy. That lets us know what you're actually working on. SS1030 is going to be a VCMX that's in a package unit. SS1030, 1032 is going to be, I want to say that's water source heat pump. SS1034 is a split system. 1045 is an RNE controller, which is almost the same board. So there's a whole bunch of SS numbers. Them are just a few. Coming down the board, you got some analog inputs. You got a 5-volt output, auxiliary voltage output. I've never used that. Down here at the bottom, analog outputs. You got a couple of them. Up top, you got configurable relays. You got some LEDs right here that you're going to be looking for whenever you're doing your troubleshooting. Board address, 24 volt power, and it is polarity sensitive, guys. If you hook it up backwards, that board will smoke. So it is very critical. All of Wattmaster boards are polarity sensitive. I had a guy some years back, actually, it was wired from the factory incorrectly. They basically took this plug and they turned it upside down, plugged it in from the factory. And my guy went, changed the board out. After 3 boards, realized, hey guy, you're doing it exactly the same. All you got to do is swap through 2 wires. So we burned a lot of boards then. Got some plugs down here on the bottom. Static pressure sensor hooks up on the bottom. I2C connection, that's for expansion devices, and you got digital sensors hooking up down there on the bottom. And we'll go through all them sensors and hookups and all that. Whenever you're looking at technical guides, always look at which technical guide you're looking at. I've downloaded, from the time I started, I got an iPad and I started downloading tech guides from the website, and through the years they update them, they change quite frequently. So especially the newer controllers, they started with revision A. There's some of them that are at revision U already, and this is in less than a year. So that's how many updates they've had. So always look at the tech guide, which one you're looking at. Part number cross reference. So this is all the expansion devices, sensors, everything you can hook up to these boards, and it's in the front of every one of the tech guides for every one of the controllers there are. Gives you a list of them. Handheld service tool. Where's that guy at? I think it is this one. Where's it at? Right there. 391-12. That's the handheld service tool. If you're wanting to use a USB link, use a laptop to connect to them. This is the part number you're going to be looking for. OE366. Differences between handheld service tools and USB link laptop version of it. You got the scroll on bottom, you got a scroll on top, and it's compressing gas. Just in simple terms, you got a solenoid that you got a port that comes off the discharge, in which this I'm just trying to make it simple so y'all understand. And it pushes pressure down on the top scroll, keeps it engaged. It's compressing gas, it's moving gas forward, it's loaded. If it needs to reduce capacity of the compressor, there's a solenoid valve that goes either external unloader or an internal unloader. It comes from that top section, it goes back to suction, and it allows that top to shift up. That top scroll shifts up, gas starts bypassing internally. They say that these guys, when they talk about digital compressors, that they're 100% modulating. That's not all the way true. It's either loaded or unloaded. It's not like a screw compressor where it's got a piston where it's driving underneath back and forth. These guys do it on a time cycle. So 15-second time cycle is what they're looking at. So if they want that compressor to run 50% capacity, they load it for 7.5 and they unload it for 7.5. Compressors run at 50% capacity. So that's how they're doing it. They're doing it with a compressor protection module. And we'll get into that here a little bit later. Are all y'all familiar with hot gas reheat? It's different from hot gas bypass. Hot gas reheat uses a separate coil that goes just downstream of the cooling coil, and instead of sending the discharge gas to the condenser to remove the heat, they're actually reusing that energy, they're capturing that energy, and they're reheating the air back up. So what I can do is I can draw just a quick drawing of it. Compressor, you're gonna go down, condenser, receiver tank. I'm gonna go check it out. Heating device. Check it out. Accumulator if you need it. So what you got now is you got a valve. The older style, you had a valve there, had a valve here. So hot gas reheat, so this is your condenser, this is your evap, receiver, accumulator. So instead of sending the discharge gas to the condenser, you're actually sending it over here to a coil. So you can actually run, let's say a 40-degree coil, which should produce roughly about a 50-degree leaving air temperature. And you can use this hot gas here to reheat the air back up to, let's say, 70. So you're actually able to dehumidify it here and then re-expand the air right there so that it's not overcooling or overheating the space. And these guys are just check valves. Gas is going this way, it's coming through. So if it's modulating this way, it keeps it goes